in the last class. So we were stuck at this problem. We were not sure how to prove that ratio of these three things is 2:2:1. Okay. Did anyone work on that at home on this problem?
Sir, I think I got it.
Yes, Varun. So how do we start?
Yeah, sir. So last class we got that those two are equal. First two.
1 second. I'll give the names for them. Yeah. Yeah. So I'll name them. Say this is A. This is B. C, D, E. Yeah. Yes,
So
Varun.
we got ED is equal to DC.
Yes, we got ED is equal to DC in last class. That is by midpoint theorem. Yes.
So if we see the triangle which is below ED, that triangle below ED,
Okay.
we by this midpoint theorem we can get that the side parallel to ED is half of ED.
Okay. I'll name that also. Say this is F, this is G, and this is H. Yeah. So
So
yes.
we get ED is equal to 2 times FG.
ED is equal to 2 times FG. Very good. What next?
So FG is equal to half of ED.
Yes. Then
ACB is this congruent to FGH. So
AC,
CB.
okay, ACB is congruent to ACB is congruent to
FGH.
is it FGH or HGF, right?
HGF, yeah, HGF.
Very good. So we have to be careful with the vertices. We have to write the corresponding vertices in the same order. Okay, then
So FG is equal to CB.
so this implies BC is equal to FG. I am taking the B and C here and F and G here. Okay, last two variables. So what does this imply?
BC is equal to half of ED.
This implies BC is equal to half of AD. That is from here. Correct? Yeah. Yeah. So hence proved that uh, these three are in the ratio 2:1. So if we take this as a x, give me 1 second. So if I take this as a 2x, this will be 2x, this will be x. Similarly, you can prove for other sides also. You'll get 2x, 2x, x. Similarly, we'll get this as 2x, 2x, and x. And we'll get this as 2x, 2x, and x. And anyways, once we get this, we can get the value of x by applying Pythagoras theorem here, correct? We can apply Pythagoras theorem here. And what do we get there? What do we get there? We get 20 square plus 10 square equal to 5x the whole square, correct? Or 500 equals 5x the whole square. What do we want? What do we want? What exactly we want? We want area. What is the area of the square here?
4x square.
4x square. So this implies 500 equal to 25x square. So how much will be 4x square? So this 4x square will be 80. Correct? Because from here 500 equal to 25x square. So 5x square will be 100 if x square is 100, 4x square will be 80. So that is the area of this square. So this is another simpler method to solve this problem. Yeah. Now we'll discuss surface area of cone. We want to find out the formula for surface area of cone. Can someone tell me what is the procedure for this? I think even this was given as a homework. Did anyone solve this? Surface area of cone. What could be the approach? We have a circular base with the radius r and height of the cone is h. And for some reason they have given another measurement, that is the slant height, which is L. So what can we say about this?
We can try to construct the net of the cone first.
One second. Shashank is asking, should we message to host or co-host? Shashank, like now you have replied to host or co-host, like whichever thing for which you have replied now, reply to that one. I'm not sure whether that is host or co-host. I think that is co-host, I guess. Reply to like whatever to chat you have replied now, reply there only. Yeah, co-host then, fine. Yeah, yes, yeah, someone said something. Yeah, what is given?
We can try constructing the net of a cone.
We can try constructing
The net of a cone.
net of a cone. What does that mean?
Net means it's like a 2D surface that if you fold appropriately, you get a cone.
Yes, yes. So cone is formed. In fact, it's formed by a 2D paper actually. So if you cut the cone along one of the sides, okay. So what you get is you will get a shape like this. Okay, so you will get a shape like this. Now if you say fold it along say one of the edges here, you will get the actual cone. I hope you are able to imagine that. Now all that I have to find is surface area of this base of the cone and also lateral surface area, correct? I have to find this area. Surface area of the base of the cone is straightforward. Can someone tell me what is the surface area of the base of the cone? Muralidhar?
Pi r square.
Pi r square. Yes, Satvika, you're also correct. It's pi r square because it is a base is a circle with the radius r. So surface area of the base of the cone is pi r square. To that, I have to add surface area of the slant surface area. And when I open the cone, we got a shape like this, correct? If I'm able to figure out what is the area here, that is nothing but slant surface area of the cone. How do I get that? Do I have any information about say this curve or this curve, any of the curve?
The radius of that sector is the slant.
Yes, radius of this sector, say this is called a sector. Sector means it's a part of a circle. And whenever there is a circle, there is a term radius. So radius is L, correct? So what we have done is we have taken this and we have opened this, correct? So when you open this, you got this as the sector and this is the radius of that. Now, what else do we know?
Length of the arc is 2 pi r.
Length of the arc is 2 pi r. Why is that? Because this arc is nothing but this circumference, correct? This arc is nothing but this circumference. So we have cut it open somewhere and it was like this and we opened it and we got the base circumference to be like this. This length and this length are same. So we have, this is 2 pi r. If I know length of the arc and the radius, how do I get the area?
We can first find the angle that the two radii make, and then we can use the standard result of area of sector is theta r square by 2.
Okay. Suppose we do not have idea about them, then what do we do? That formula, like I think you guys have taken for granted, I guess, finding the theta when we know uh, the
No, that comes directly from the formula of area of a circle, right?
okay, okay, yeah. So yeah, area of the circle is pi l square, and yeah. So continue. Yeah, so continue what you wanted to say. So how do I get
Yeah,
theta?
yeah, we can get theta because we know the circumference is 2 pi r, right? So the circumference can be written as r L theta. 2 pi r is equal to L theta.
Yeah, 2 pi r is equal to
L theta.
l theta. Okay.
We find theta and then we substitute it in the formula for area.
What is the formula for area?
Yeah, the theta r square by 2.
How did we get that formula?
Because pi r square by 2 can be written as 2 pi r square by 2 and area is directly proportional to theta, right?
Yes, that is true. Yeah, that's what I wanted to hear. See, if this end, if I if I wanted to find the entire area of this circle, then it is covering a bigger angle. Correct. Now it is covering only a portion of that angle, and I'm just interested in this area. So theta is directly proportional to area. Like how much angle you cover, the more the angle you cover, the more area you get here. Okay. Uh, Similarly, there is one more analogy. The perimeter, or rather the arc length, is also proportional to area. Or I can say circumference is proportional to area. Okay. But we know that a circle with radius L, circle with radius L will have perimeter as 2 pi L, correct? Circle with radius L will have circumference 2 pi L. What is the corresponding area for that circumference? Means 2 pi L means it will cover the entire circle, correct? It will cover the entire circle. What is the corresponding area for this one? Pi L square. Very good. Yes. Corresponding area will be pi L square. But I am interested in only this much circumference and the corresponding area. Okay. How much is this much length? It is 2 pi r. Is 2 pi r. So what is the corresponding area? That we have to find out. So we will get A1 as pi L square into 2 pi r divided by 2 pi L. So 2 pi and 2 pi gets cancelled. L and one of the L gets cancelled. We'll get pi L r. Correct. So the cross-sectional area, I mean this area is nothing but pi L r. So for that we have to add the base area. So this is my total area or surface area for cone. And what is L in this? We can apply Pythagoras theorem. L square is equal to r square plus h square. In other words, I can write L is equal to square root of h square plus r square. This is also important. Let's see some questions on this. We have a question. The red figure at the right is made up of two hemispheres of equal radius. The blue cylinder at the left has the same radius and height as the red figure. Which shape has the larger surface area? Which surface area has the larger surface area? So, okay, I wanted to write which figure, but I wrote which surface area. Fine. So, most of you have written red. Some of you written blue and some of you written equal areas. Let's see what is the answer. Uh, okay. What can you say about the height of the cylinder? What can you say about the height of the cylinder? Can you speak up, someone, and tell me so that everyone can hear us?
Twice its radius.
Twice its radius. Yes. So this height is 2r because they have told cylinder at the left has the same radius and height as the red figure. Okay. So if you consider this is 2r. Why this is 2r? Because this is the radius of the half of the sphere, and this is also radius of the another half of the sphere. So height of the cylinder is 2r. So what is the formula for surface area of a hemisphere? With the base. Say I have a hemisphere like this. With the base, including this top portion, what is the surface area? We had discussed this, no? Yeah, Kishan, can you tell me the answer in over mic?
Sir, 2 pi r square.
That is with the base or without the base?
So without the base, if you add the base, it becomes 3 pi r square.
Yes, very good. So without the base, I mean only the lateral surface area, it will be 2 pi r square. If I include the base, it is a circular base, another pi r square I have to add. So surface area of a hemisphere is 3 pi r square. But we have two of them, one here and one here. So surface area of this pink figure or the pink spheres is 2 times 3 pi r square, which is 6 pi r square. Okay. What about this cylinder? What is the formula for surface area of a cylinder? Again, remember, we need to include the top and bottom surfaces also along with the lateral surface. How do I get that part? Yes, the formula is 2 pi r into r plus h. 2 pi r into r plus h. We had seen this in the last class. So, but what is h in our case? What is h? 2r. Yes, it is 2r. So we get 2 pi r into r plus 2r. This implies 6 pi r square. So both the figures have equal areas. Okay, so both the figures have equal areas. I think, but most of you had written pink has more area, which is wrong. Okay, so the calculation part is like very, very simple here. 2 into 3 pi r square, 2 pi r into r plus 2r. Only this much calculation we had to make. Okay, isn't it simple, this problem? So next problem is also like very simple. Everyone should try to answer this. So what is the answer for this? So if the diameter of a sphere is decreased by 25%, then by what percentage does its surface area decrease? Okay. So everyone knows that diameter is directly proportional to radius, correct? So diameter is directly proportional to radius. So if diameter decreases by 25%, radius also decreases by 25%. For example, say diameter was 100, it decreased by 25% means it became 75. And say if the diameter is 100, it decreased by 25%, it became 75. If the diameter is 100, radius will be 50. And radius here is nothing but 75 by 2, which is nothing but 37.5. Now, if you compare 37.5 and 50, 37.5 is 25% less than 50. Okay, so that's the relation we have with diameter and the radius. Now, what is the relation we have with the diameter and say area, surface area? R square, yes. This one is R square. So because our formula is, area formula is, what is the area formula? 4 pi r square, right? 4 pi r square. So as you can see, A is directly proportional to R square, or I can say directly proportional to D square. Correct? It is directly proportional to D square. Now, D has decreased by 25%. Correct? The diameter of the sphere has decreased by 25%. That means, say initially D was at 100%, and now it has become 75%. Okay, now it has become 75%. Or rather, you can say, say initially it was say x, radius was x. Now it has become 3x by 4. Now say my surface area, say initially it was A. Now what is the case? Okay, that we have to figure out. Say this is A1, and we know that A is proportional to x square and A1 is proportional to 3x by 4 whole square. Correct? How did we get this? This we got from this relation. A is proportional to square of the radius. Correct? It's proportional to square of the radius. The radius initially was say x. It has become 75%, which is 3x by 4. Area, it has become A1. Now you divide one by the other and you will get the ratio. Okay, but they have asked by how much percentage it has decreased. So what we have to do is A minus A1 divided by A. We have to find this value. Okay, if I want to find this value, what do I get? X square minus 9x square by 16 divided by x square. Correct? My A is proportional to x square. My A1 is proportional to 3x by 4 whole square. And I'm dividing it by the corresponding A here. I hope you know this. Like when two things are proportional, I can do these operations. I can subtract, I can take the ratios of the areas. Okay. Simplifying this, I'll erase this part. This is not needed. Simplifying this, we get A minus A1 divided by A equal to 7 by 16. And if you want to take the percentage, it comes out to be, I think, 43.75 or something. You just take the decimal part of this and multiply it by 100. You get 43.75 as the percentage. Okay, by this much percentage, it has decreased. Okay. So just go through the solution again if you're not clear. And if you're clear, you can go to the next question, which is on the bottom of your screen. Suppose the surface area of a circular cylinder with height h and base radius r is half the surface area of the circular cylinder with height phi h and base radius r. What is the ratio of r to h? So most of you answered 3:1. Yeah, that is the correct answer for this question. Let's see, how do we approach this problem? Surface area of a circular cylinder with height h and base radius r. So we'll make a table here. So radius in both the cases is r and r, correct? That is what given. Base radius is r, and here also base radius is r. What about the height? Height in this is first case, this is second case. Height. say this, we'll take this as say h1. What is the relationship between h1 and h2? Say first case and second case. In the second case, height is 5h. Okay, and what they have told about the surface area, say area. See, if I take this as a, this will be 2a. Correct? This much information I have. Surface area in the first case is half of that of the second case. Now, what can you say about a? What is the formula for a? A is nothing but surface area of the cylinder. What is the formula? Srijan Rao, what is the formula for surface area for the cylinder?
2 pi RH.
2 pi RH. If I want to include this one, basis.
2 pi R into R plus H.
Yes, very good. So it will be 2 pi R into R plus H. And in second case, my area has become 2a. My radius is same. All that has increased is height, which has become 5h. Okay. Now we'll divide first equation by the second equation. What do we get? We get a by 2a, which is 1 by 2. 2 pi r and 2 pi r gets cancelled when I divide these two. So all I'm doing is dividing this by this. So I get r plus h, which is equal to r plus 5h. If you simplify this, you get, by cross multiplying, you get r plus 5h equal to 2r plus 2h, or we get 3h is equal to r. They have asked what is the ratio of r to h, so we get r by h is equal to 3. So this is your next question. Suppose that the surface area of a circular cylinder is 20 pi. If both the radius r and height h of the cylinder are integers and r is greater than 1, what is r plus h? How do we solve this? Can someone help me to solve this problem?
So we can equate the formula of surface area of a cylinder to the 20 pi.
Yes, we can equate the formula of surface area of a cylinder to 20 pi. The surface area of a cylinder is 2 pi r into r plus h. This is equal to 20 pi. What do I do next?
So cancelling out 2 pi, then it becomes r times r plus h equals 10.
So what do we get is r plus r into r plus h is equal to 10.
It's given that both are integer and r is greater than 1, so r could be 2, most probably, because it's integer and greater than 1.
Yeah.
R
So,
should be 2.
yeah. So why did you assume that r could be 2? Can it be 3 or 4 or 5 also, right? How did you come to the conclusion that r has to be 2?
So if we'll take r to be 3, then we'll get some like r plus h will be, first of all, it will become like fractional, and if we'll substitute again in 2 pi r times r plus h will not get the same answer, 20 pi.
Yes, true. So what he's trying to say is, if suppose if I put r is equal to 3, then simplifying this, we get r plus h. This implies r plus h is equal to 10 by 3. Now again, r is equal to 3 here. I'll substitute r is equal to 3. We get 3 plus h is equal to 10 by 3. Or h we will get as a non-integer number. So suppose this was a very big number. Can we keep on guessing it, or is there any shortcut?
We can write r plus h is equal to 10 by r. The same equation we can write.
Okay, I'll write that for you. R plus h is equal to 10 by r. Then
Now it is sufficient only if we try for the factors of 10.
yes, very good. So that's what I wanted to hear. See here, I know that both these numbers, that is r and r plus h, have to be integers. Why? Because r is anyways a integer and h is also integer. So if you add two integers, you'll get integer only. Correct? So these two have to be integers, and these two have to be a multiple of 10. Correct? It has to be a multiple of 10, because when you are multiplying two numbers and you're getting product as 10. So these two has to be of factors of 10, not multiple, factors of 10. So what are the factors of 10? We have 1, 2, 5, and 10. So what are the two numbers? If I multiply 1 and 10, I'll get 10. If I multiply 2 and 5, I'll get 10. But can I use r is equal to 1? Can I use r is equal to 1 and r plus s is equal to 10? Can I use that? Can someone speak up?
No, so we can't use that.
Yeah, we can't use r is equal to 1 because it's given that r is strictly greater than 1. But can we do other way around? Can I use r equal to 10 and r plus h is equal to 1?
That's not possible.
That's not possible. The moment I use r is equal to 10, and this will become r plus h will become 1. This implies that h is equal to minus 9 because r is equal to 10, h will be minus 9, r plus h will be 1. So which I do not want. I do not want h to be negative. So all that we are left out with is 2 and 5. Let's say r is equal to 5 now. If I take r is equal to 5, say if I write this as 5 into 2 equal to 10, then r plus h will be 2. So again, this implies h is equal to minus 3. Even this case is wrong. So we cannot use this case also. So only that case that is left is taking r is equal to 2 and r plus h is equal to 5. So this implies h is equal to 3. Anyways, r is equal to 2. So r plus h will be 5. Only this case is valid. So our r plus h will be 5. Okay. So most of you have written 5 as the answer. Some of you have written 10, 9, and 2 as the answer. This is your next question. In the poll, the question is not complete. I think it is limited to some words. So the area of the square base is, it has stopped here. Okay, rest of the question is not printed in the poll. Actually, I want the entire question. Answer for this question. Anyone who has written 96 or 60 can help me solve this problem.
So we can open the pyramid and we can see that it is like 1 square and 4 isosceles triangle.
Okay, it is 1 square and 4 isosceles triangles. So in the bottom we have a square and we have 4 isosceles triangles like this. Correct? Yeah.
Yes, sir. And it's given that the height is 4 and we can see the that from middle to the edge it is 3. So we can find the height of the triangle by Pythagoras, it is 5.
Yes. Yeah. So we can figure out that. In fact, this was not given in the problem. Okay, this was the construction which I had made. So only this much information was given. Anyways, so I had started the construction. I'll rewrite here. So this will be 3. Why this will be 3?
So 6 by 2.
Yeah.
Because the apex will be at the
Yeah. So this apex and the center of the circle, and that line is perpendicular to the surface of the square base. So this will be at exactly center. So if you draw a perpendicular from this point to the any of the edges of the square base, it will be parallel to the one of the square base, and also it will be perpendicular here, and this length will be half of this length. So if I say name this, say O and F, OF will be 3 units. Now, how do I figure out what is BF?
Pythagoras theorem.
Yes, I can apply Pythagoras theorem. Yeah, I can apply Pythagoras theorem. So we get BF square is equal to OF square plus OV square by applying Pythagoras theorem for this triangle. Imagine that this is a slant height and this is the pole. This pole we have here. Okay, and this is the base. Something like this we have. If you imagine, try to imagine this figure in 2D. So OF square is how much? 3 square, which is 9. OV square is 16. So this will get us 25. So VF will be 5 units. Okay. So VF will be 5 units. Now try to imagine this plane. Okay. The rightmost plane. So this is a part of a triangle. And if I consider this as base, can I consider this as the height? Ketan?
Yes, so you can consider that as an height.
Yeah, I can consider this as the height. Okay. And this height is nothing but 5 units and it is perpendicular to the base and the base is 6 units. So what will be the area of that triangular surface?
Half times base into height.
Area will be half times base, which is 6 units, into height, which is 5 units. We will get it as 15. And how many such units are there?
4.
4. So we have 4 surfaces and area of all those surfaces is 60. Okay, I think most of you have got this as answer, and some of you added 36 to that and you have written 96 as the answer, which is wrong. They have asked what is the total area of the 4 triangular sides in square meters. They have not asked anything about the area of the square base. Okay, I hope this is clear. We'll go to next problem. I think here most of you answered B as the answer, 3:1. Let's see if it's correct or not. Around 47% of you have answered that B. Okay. Let's consider a simpler problem here. Suppose instead of having 8 slices, let's see what happens if I divide an orange into 2 equal slices. Okay. First of all, how much is the area that I already have, the surface area around this orange?
4 pi r square.
Very good. So till now I have 4 pi r square. The original orange has 4 pi r square. The new, whatever the slices I make, it will have the original outer area, plus for that some area will get added as I keep on slicing it. Let's say you slice along the horizontal axis like this. Okay, so you are slicing it along the horizontal axis. I'm just making 2 slices. So what happens that time? So you will get one slice like this and you will get another slice like this. Correct? What is the area that got added here?
2 circles, that is 2 pi r square.
Yeah. So for this slice, one circle area got added, and for this slice, another circle area got added. Correct? So and the radius here is r. Here is also r. So the moment I make, say, I have 2 slices, pi r square plus pi r square, 2 pi r square got added. Now suppose instead of slicing like this, I am having just one vertical slice like this. Correct? So that time what happens? So that time I'll have correct? Again, I'm cutting it like this. So now also I have this pi r square and pi r square as a surface area. Correct? Now consider only this part here. Now if I do the horizontal slicing like this, now if I do horizontal slicing like this, so this, whatever the half of the this hemisphere is there, no, it will get this much area, extra area, because of the first cut, and in the bottom there is another pi r square by 2 area which get added. So pi r square by 2, pi r square by 2, pi r square area will be there. Similarly here also, bottom surface here and the top surface here. Correct? So basically I am cutting it like this now. Okay, we will have area forms along this axis. So whenever you make a cut, the whatever this area was there, no, that will get half, but for that another area on the uh, sides will get added. Okay, so now there are, when I cut this, now there are 4 parts. I can say cut like this, and then I can cut like this, or initial I can cut like this and then I can cut like this. So each and every part will have pi r square as the additional added area. Correct? Is that true? Did you follow this, students?
Yes, sir.
Yeah. So for every slice you add, I mean, every cut you make, a pi r square area will get added. So if it was say 4 slices, this will be 4 pi r square. Now, continuing our whatever what we have seen, now we have 8 slices. So 8 pi r square will get added to the original this one. So if it was 2 slices, my answer would have been 4 pi r square plus 2 pi r square. If it is 4 slices, my answer would have been 4 pi r square plus 4 pi r square. If it is 8 slices, my total area will be 4 pi r square plus 8 pi r square. Erase the unnecessary things here. So 8 pi r square gets added. So totally, which is 12 pi r square. So what they have asked? They have asked for the ratio of new total surface area, which is 12 pi r square, to that of original area, which is 4 pi r square. So you get answer as 3:1. 3:1 is the answer. Okay. We'll see. We'll discuss one of the question which was given as homework in the last class. Okay. I'll give you 30 seconds to answer this, and after that we'll discuss this question. So in this, the question is, in a spherical ball, a large number of dimples have been carved. The shape of these dimples is a part of a sphere. That is, each of these dimples is part of some sphere. Okay. Is it possible for the dimpled ball to have a smaller surface area than it had before the dimples were carved? Can anyone wants to try and explain why is it yes or no? Can anyone speak up?
Just an instinct, sir.
So did you answer yes or no?
I answered no.
No. Okay. Srivatsa, what did you answer?
No, sir.
Okay, you said no. Any particular reason to say no, or it is just an intuition?
No. It appeared to me like the area of the depression is more than the area of the circle.
Okay. Yeah.
So
Yes.
I thought it will always be greater.
Yeah. So I mean that's what we tend to imagine, because the area of the depression will be more than the original circles, because the figure is put up in such a way that it is making you feel that the depression area will always be more than that of the original area. But let's see if that is the case. So I'll share my other screen. Just give me 1 second. Okay. I hope my screen is visible now. Yeah. Now assume that the blue ball is my original ball. Okay. And now I am creating a depression in this. Okay. I am removing this part of the ball, and suppose I'm just creating one depression in that. Now, what do you think? The depression surface area, is it less than or more than the original ball area of this area?
It is less than.
It is less, right? Now, what if I decrease this value, the radius of the yellow ball? What if I decrease the radius of the yellow ball and I move the, okay, now I'll zoom it. Now, what do you think has happened? Now I have decreased the radius of this yellow ball, which is creating the projection inside like this. Now, if you compare here, I have surface area, original surface area was this one, and this is the dimple. What do you think? The surface area of the dimple is more or less?
More.
More. So it all depends on with what sphere are you creating this dimple. Okay. If you take a bigger sphere compared to that of the original sphere, you will get lesser surface area. If you take the smaller sphere compared to that of original sphere, you will get a surface area more than dimple surface area is more than that of the original one. Is this clear? Or still you have doubt?
Sir, so what was the answer, sir?
The answer is yes. We can have a, what was the question again? Is it possible for the dimple ball to have a smaller surface area than it had before? Yes, it is possible. So it is possible to have smaller surface area as well as larger surface area. It all depends on with what sphere are you making that dimple. Okay, or you can reverse the cases here. Assume that the yellow ball here is your original ball, and now you're trying to make the dimple. Initially, this was the actual ball here, the surface area. You're making a dimple with a larger ball. So this is the dimple which has formed. If you compare the surface area from inside of the figure here, it is less than, dimple's area is less than the original ball because the dimple was made by a bigger radius ball. Okay, is this clear now? Not clear? You have to answer me.
Clear, sir.
Okay, fine. So I'll give you break for 5 minutes. Now it is 5:47. By 5:52, you have to be here. Okay. After that, we'll start discussing about volumes. Okay. So we'll continue now. So we'll quickly go through a couple of formulas, which you already know. Most of you already know. So first of all, volume of a cuboid. So if you have a cuboid, yes, answer is correct, ABC. If you have a cuboid with length A, breadth B, and height C, how do you get the volume? You just multiply all the three numbers, you get volume as A into B into C. Okay, that is the straightforward answer. What if it was a cube with the length A? If it was a cube with length A, it will be A into A into A because all the sides will be A. So it will be A cube. So this is the volume of a cube. And the next one is a volume of a cylinder. Okay, the next one is volume of cylinder. Yes. So can someone tell me what is the volume of a cylinder over the mic?
Pi r square h.
Pi r square h. Yes. So here what exactly we are doing is we are taking one plate with radius r. Okay. And we are keeping many plates one above the other. So we are stacking like this. Okay. So pi r square, 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 pi r square. How many times we do? We do not know. But what is this height? This height is h. So we can, in a vague manner, we can say that we are stacking pi r square for h height. So that is the reason volume of the cylinder is pi r square h. Like this is not actually correct, but still okay. In reality, we'll be integrating it, or maybe we are using some other technique to get the volume. So this is a vague way to tell. We are stacking pi r square plates for a height of h. That's why I'm multiplying pi r square to the h. In the previous case also, you can say something like this. I am stacking rectangular plates of AB, area AB, for how much height? For C height. That's why I'm multiplying base area to the height C. So it will be A into B into C. Okay. Yes, Ketan, that is correct. With integration rotating y equal to say about x-axis, we get the formula. That's true. Yeah. So we'll actually derive this formula maybe in first PU or second PU. For now, let's take it for granted. Okay. Next one, volume of a pyramid. Volume of a pyramid. Can someone tell me what is the formula of volume of a pyramid? Or can someone tell me what is the formula for volume of a cone? I think this one you have already learned. Volume of a cone.
1 by 3 pi r square.
1 by 3 pi r square h. I think that you have learned. What is pi r square in that? So you had learned that volume of a cone is 1 by 3 pi r square h. This is for the cone. Okay. What is this quantity pi r square in that?
Base area.
Base area, because my cone will look something like this. So this is my cone. In that, base area will be pi r square. For that, I am multiplying, this is pi r square. For that, I am multiplying h by 3. Now you have the base area here. This is a pyramid, but the base is not exactly circular, but some shape is there. What can you say about volume of this pyramid? Base area is given. It's given as A. Use this logic. Yeah, can you speak up, Satvik?
1 by 3 AH.
Yes, very good. Yeah, so using the same logic, I can say that volume of this pyramid is 1 by 3 into H. Anyways, we will be proving this also integration, using integration in first PU. For now, take it as granted. So if you take any pyramid, okay, you take any pyramid, if you know the base area and the height, we'll straight away apply 1 by 3 A into H. So even if this vertex was somewhere here, okay, and your pyramid was something like this, okay, now the height is h, the vertex is here, still the area will be 1 by 3 into h. Let's see whether that is true or not. So I have plotted one graph for you in GeoGebra. Okay, now is this pyramid visible to everyone? Yes. Okay. Now say I have the vertices A, B, C like this, and E is this topmost vertex, and ABCD are the square base. Okay, why they are square base? Because I have taken the vertices in such a way that the z-axis is it's in the xy plane, 2, 2, 2, minus 2, minus 2, 2, minus 2, minus 2. The z-axis is at 0 for this ABCD, and the height I have kept it in on the z-axis. That's why it is 0, 0, 5. Okay, so it is bit so for some of you it might be like it is bit difficult to imagine. So this is what is happening. So this red axis and this green axis, they are my xy plane, and this blue axis is my z-axis. So in the xy plane, I have all the 4 vertices. So if you see this point, this is nothing but minus 2, minus 2, this point, because this way we have negative x-axis and this way we have negative x-axis. So this point is minus 2, minus 2. You can see here. The moment I clicked on this point, this got highlighted minus 2, minus 2, 0, because it is in the xy plane. Similarly, this point is 2, minus 2, 0. So this is 2, this is minus 2, and the height is 0. Anyway, so this is my pyramid. Now, what I'll do is I'll change the so I'll rotate this like this. Okay, so I'll move this vertex. Okay, and first of all, let's see whether the formula here is valid or not. So first of all, what I'll do is I'll decrease the height of the pyramid. Okay, So as I keep on decreasing the height of the pyramid, the volume it is getting decreased here. So so whatever the function I have written for the volume, that is absolutely correct. So I'll revert it back to the height to be 5. Okay, I'll revert back the height to be 5. Okay. Uh, Now what I'll do is I'll move the vertex. Okay, I'll move the vertex. Say I'll make this 3. Okay, so what has happened is, yes, so my vertex was at where was somewhere here, and now it has moved to the right side of the x-axis or the red axis. Still, the volume has remained same, 26.67. So no matter what you do with this vertex, so if you move further like this, okay, the height will remain same. My height is 5. I have moved the vertex along the xy plane. Okay, so the pyramid has tilted, but the base is same. The height is same. Height is 5 only. The volume will remain same, 25 or 26.67. So it doesn't matter whether you are moving the base, moving the top vertex or apex, as long as it is at the same height, as long as you are having the same square base, your volume will remain same. Okay, this is the learning, this thing we need to know. Okay, any doubt here, students? Okay, so I'll stop sharing and we'll go to volume of a sphere. I think everyone knows this formula. What is the formula for volume of a sphere? Can someone tell me what is the formula?
4 by 3 pi r cubed.
Yeah, 4 by 3 pi r cube. 4 by 3 pi r cube. Again, we can prove this using integration, but for now, we'll take it for granted. Okay. Yes, Ketan, that is correct. Okay. Now, let's try to solve some problems. This is your first question on volumes. The area of each of the 6 faces of a cuboid has grown by factor of 4 times. Then the volume of the cuboid has grown by factor of how many times? Can someone tell me how do I approach this problem?
Volume of cuboid is length into base into height,
Yeah.
breadth into height.
Yes. So, or if I take it as ABC, it is A into B into C.
ABC. Yeah. Then we increase everything by 4A into 4B into 4C. So it becomes 64 ABC.
Okay. Say let A, comma B, comma C where the original lengths, and say A1, B1, and C1 are the new ones. Okay. A, comma B, comma C is the original one, and A1, B1, C1 are the new one. What has happened? So he is telling this A1 is nothing but 4A, and this is 4B, and this is 4C. He is telling each of them have increased by 4 times. Is it the case?
No, because the area is increased only by 4 times the total area.
Yes. So what they are told is each of the surface areas increased by 4 times. So what are the different surface areas we have? We have AB, BC, and CA. Correct? These are the different surface areas we have. As you can see here, this is one of the surface area which is B into C. This is one of your surface area which is A into B. And one more is this one, A into C. Okay, and corresponding, you will have one more pair, A into B front and back, B into C right and left, and similarly A into B top and bottom, which is again same. In the new case, we will have A1 B1, B1 C1, C1 A1. And what is the relationship between these, this, and this?
By a factor of 4.
Yes, they are saying the new area is nothing but the 4 times the old surface area. Very good, Navya. Yes. So and also the person who has answered. Very good. So 4AB is A1 B1, 4BC equal to B1 C1, 4CA equal to C1 A1. The new area is 4 times the old area for each of the surface areas. What we are interested in? We are interested in A1, B1, C1. How do I get that? If I multiply all these things, what do I get? On the RHS, I'll get A1, B1, B1, C1, C1, A1, which is nothing but A1 square, B1 square, C1 square. So on the RHS, I multiplied all these three things. I got A1 square, B1 square, C1 square. Similarly, I'll multiply on the left hand side. I'll get 4 cube times A square, B square, C square. Is it correct? Now all that I have to do is take the square root, and what do I get? I get 4 cube is 64, square root of that is 8. 8 times ABC is equal to A1, B1, C1. So new volume, which is A1 into B1 into C1, is 8 times the old volume. So answer is 8 times. Okay, we'll move on to the next question. Okay, so here also, like, most of you have done the I think approach, most of your approach is correct, but some of you have answered 409, some of you have answered 309. Okay, let's see how to solve this problem. Cube has increased by 60%. What is the increase in the volume of the cube? How do I start? What should I do? I'll take the dimension of the original cube to be x. Okay, x, x, and x. So the volume here will be x cube. So what is the dimension of the new cube?
8 by 5x.
8 by 5x, or 60%. It has increased by 60%. So originally it was x. For that, I am adding another 60%, which is 0.6 times x, or this is nothing but 1.6x, or as I said, it is 8 by 5x. So the new dimensions are 8 by 5x, 8 by 5x, 8 by 5x. So the volume will be 8 cube by 5 cube into x cube. Now the question is, what is the percentage increase in the volume of the cube? How do you get percentage increase?
New minus old by old into 100.
Yes. So how do you get percentage? New volume, which is 8 cube by 5 cube times x cube, minus old volume, which is x cube. I will remove this. We'll write the volume here, okay, for this one, which is 8 cube by 5 cube times x cube. Yeah. So new volume minus old volume divided by x cube into 100 will give me the percentage. Can someone simplify this and tell me? So if I simplify this and I take the 5 cube as the LCM, I get 8 cube minus 5 cube divided by 5 cube into 100. And if you simplify this, you will get 309.6 or something, which is approximately 309%. Okay, so this is how you solve this problem. So answer is approximately 309%. So what most of you did was, I think you took the percentage. So why many of you have written 409? Why you have written 409? I think what you did was you took this 1.6 and you took the cube. 1.6 cube is approximately how much? So we'll erase this. This part is not needed now. So I think what
Sir, I guess they forgot to subtract. That is, increase is given by uh, a new area minus original area divided by original area into 100, right? They did the new area, new volume divided by original volume into 100.
yes, yes. So what you did was you found out the new volume, which was like 1.6 times x cube. 1.6 x cube is nothing but say 1.6 whole cube into x cube or this is same as what is I can for now I'll write this as I want to find 16 cube. How do I find 16 cube? 16 cube is nothing but 2 power 4 to the power 3, which is 2 power 12. I know generally everyone knows how much is 2 power 10, which is 1024. 1024 2 power 10 is 1024 into 2 square, which is 4. So you get 4096. As it is 1.0, 1.6, you will have 3 decimal places. So what most of you did was, and for this you multiplied by 100 and you wrote it as 409.6%. So you didn't subtract the original volume and to get the actual increment. Actual increment is only 309%. Okay, that's the mistake we make. Like we get the answer and still we read the wrong answer. So you have to be little bit careful while choosing MCQ question, choosing answer for MCQ question. Okay, so we'll check one more problem. I'll read the question for you. A cube with side length of 1008 units is dropped and completely submerged in a cube-shaped container. With the water level in the cube-shaped container rises to 52 units. Find the length of a side of the cube-shaped container. Can someone tell me how do I start this problem? How do I approach? Yes.
The increase in
volume of the
Yes. Yeah, one of you continue.
the volume of the submerged cube is
You
equal
can
to the
consider
volume
the
of the
big cube as side of A. So it's given.
Ketan, Satvika, can you speak up? Ketan can answer next question. Yes, Satvika.
Okay. The volume of the submerged cube is equal to the volume of the cuboidal water column that's increased.
Yes, true. Yes, next after that.
So we can equate the volumes and we can find the length of the edge of the container, larger cubical container.
Yeah. So what Satvika is saying is volume of this cube is same as volume of the water level which has increased. Is this true? Can someone else verify this? Is this true? Have you learned this concept anywhere?
yes, sir, in physics.
Where is
Yes,
it?
in physics it is.
Physics. What do you call that principle?
Archimedes
Archimedes
principle.
principle.
Archimedes principle.
You have learned this. In fluids, you have learned this is Archimedes principle. So whatever object you put inside a water, volume of that is same as volume of the water which is displaced. In our case, volume of the water that is displaced is around this much water. And they are telling level of the water in the container has increased by 252 units. So basically, this much amount of water has increased. Correct? Originally it was here and this much it has increased. And the height that has increased is 252 units. So originally it was here and this height is 252 units. All that I need to know is base area of this square. So volume displaced is nothing but base area into 252, which is same as volume of the cube, which is same as volume of the cube that we have dipped. Okay, which is nothing but 1008. So can I compare this and can I get the base? This is 1008 cube. Sorry. Yeah. How do I get the value of base? Or say B is equal to 1008 square into 1008 divided by 52. Any idea why I have written like this 1008 square into 1008 by 252?
Easy for calculation.
Yeah, easy for calculation because I know that base is a square area, correct? So if I have square and some number with the square, I can directly take the square root and get the original length. So this is nothing but 1008 square. What is 1008 by 252?
4.
4. Very good. So this implies 1008 square into 2 square, or 1008 into 2 whole square. I don't know why I'm writing all the steps. So it is 2016 whole square, which is nothing but b square, or which is nothing but side length into side length. So side length will be 2016. So yes, most of you answered correctly. 2016 is the answer.